Medication calculation. It's really not as complicated as it seems. Once you learn a few simple skills, you will be on your way to calculating and administering medications in no time. Hopefully, this presentation will help you with that. To be able to understand an order, you first must understand a few basic abbreviations. These include daily, which means that a medication is to be given once per day. PO means to be given by mouth, like a pill. And GTT means drop, such as a drop of water. So, let's give a PO medication. You have an order for 45 milligrams of medicine X to be given by mouth every day. You have a bottle of medicine X tablets available. Each tablet has 15 milligrams. How many milligrams should be given? Let's simplify it. We know that in the end, we need to have 45 milligrams given to the patient, and that we have tablets with 15 milligrams in each one. How many tablets should be given? Let's set up our problem like a proportion. We have 15 milligrams in each tablet. We're going to place the 15 milligrams above the one tablet. Just like there are 4 quarters in $1, there are 15 milligrams in one tablet. Let's set up the rest of the problem. Similar to how we have a total of 15 milligrams in one tablet, we have a total of 45 milligrams in our X number of tablets. Let's multiply. Multiplication will yield our proportion. 15 milligrams times X equals 45 milligrams times one tablet. Since we can't multiply 15 milligrams by X and really get anything, let's multiply 1 times 45. Remember, we are multiplying the numbers, so the units will remain. 1 times 45 yields 45. Who could have guessed? Now, to solve for X, our mystery number of tablets, we have to get X by itself on one side of the equation. So, divide each side by 15 milligrams. First thing we can do and get rid of is the 15 milligrams on the left. So, scratch that out, which leaves us with X equals 45 milligrams per tablet over 15 milligrams. Let's simplify it and get rid of the milligram units on the right. Scratch it out. And now we can divide 45 by 15. Remember to retain that tablet unit, and so it is 45 tablets divided by 15, which yields 3 tablets. In summary, 45 milligrams were to be given, 15 milligram tablets were available, so 3 tablets were given. 3 tablets of medicine X in 15 milligram unit doses equals 45 milligrams. Next up are PO liquid medications. We have an order for 200 milligrams of medicine Y to be given by mouth 3 times per day. Let's break it down. We want to administer 200 milligrams of medication. We have a solution with a concentration of 125 milligrams per 5 mils. The question is, how many milliliters should be given? Let's set up the problem. Just like we had 4 quarters in $1, we have a total of 125 milligrams in 5 milliliters. On the other side, we have a total of 200 milligrams in our mystery number of milliliters. Let's multiply. Multiplication yields 125 milligrams times X equals 200 milligrams times 5 milliliters. Multiply 5 times 200, which yields 1,000 milligrams per milliliter. Remember to retain these units. Now, to get X by itself, divide each side by 125 milligrams. Simplify it by scratching out the 125 milligrams on the left and the milligram units on the right. Then divide 1,000 by 125, being mindful to retain the milliliter units on the right. This gives us 8 milliliters, because 125 goes into 1,000 8 times. In summary, 200 milligrams of medication was ordered to be given. 125 milligrams per 5 ml of solution was available. 8 milliliters of 125 milligram per 5 milliliter of medicine Y equals 200 milligrams. Next, IV medications. IV medications are mixed into a specific amount of fluid and given over a specific amount of time. Often, the amount of fluid in the IV bag, including the medication, will be slowly released from the bag in a certain number of drops per minute. This number of drops per minute is called the drop factor. This drop factor is often different from one medication to the next. So, let's look at our order. We have an order for IV medication to be administered in 50 milliliters of normal saline over the course of 20 minutes. We know the drop factor for this particular medication is 60 drops per milliliter, so in each milliliter there are 60 drops available. We want to know how many drops per minute will the IV medication be given. Let's set up the problem. The number of drops per minute can be found by dividing the number of drops in the 50 milliliters by 20 minutes. Similarly, we can calculate the speed of a car going 60 miles per hour by dividing the number of miles by the time. Back to our question. We can see how many drops are in a minute by dividing the total number of drops by 20 minutes. Well, let's figure out how many drops we have in that 50 milliliters. We know that the drop factor is 60 drops per milliliter, so the total amount of solution times the drop factor will give us the total number of drops. Put it together, and our number of drops is the same as the amount of solution times the drop factor over 20. Plug it in, and that's 50 milliliters times 60 drops per milliliter over 20 minutes. Let's start solving stuff. We can scratch out the milliliter units, then multiply 60 times 50, which gives us 3,000 drops over 20 minutes. Divide it down, and you get 150 drops per minute. In summary, 50 milliliters were to be given to a patient over the course of 20 minutes. We were to find the total number of drops that would drip per minute with a drop factor of 60. We multiplied the drops per milliliter by the milliliters and divided by our time. This gave us our drops per minute. Medication calculation. Practice, practice, practice. Practice not only for your grade, but for yourself and for your patients to come.